Welcome, everybody, to Highwire's Best Practice webinar series. Today's webinar is on the practical use of artificial intelligence and machine learning in the scholarly publishing process. My name is Tony Alves. I'm Senior Vice President of Product Management here at Highwire. I'll be introducing today's topic, and I will be moderating questions and discussion. We have a well-informed and accomplished panel today, but first, let's do some housekeeping. This webinar is being recorded. That recording will be shared after the meeting. I think it'll be up tomorrow. That recording will be freely accessible, so please feel free to share it with your colleagues and friends once it's available. We will have a question and discussion session after the presentations. That has been really popular, and we've had a lot of really good questions and discussions. So I am asking you to hold your questions to the end, we will address your questions at the end, but please put your questions in the question box as you think of them, and that way we can address those later. And then following the webinar, feel free to check out our blog post on AI and human interaction. The URL is there. But don't do that now, do that later. So just as way of introduction, people often use artificial intelligence and machine learning interchangeably, especially when discussing big data or predictive analytics and other types of computer-assisted processes. So I want to define our terms. What is artificial intelligence? AI refers to the use of technologies to build machines and computers that have the ability to mimic human intelligence, such as being able to see, understand, and respond to spoken or written language, to analyze data, to make recommendations, etc. What is machine learning? Machine learning is a subset of artificial intelligence that enables a machine or system to learn and improve from experience. Machine learning uses algorithms to analyze large amounts of data, to learn from the insights, and then make informed decisions. AI allows a machine to simulate human intelligence to solve problems. Machine learning allows a machine to learn autonomously from past data. With AI, the goal is to develop an intelligent system that can perform complex tasks. With machine learning, the goal is to build machines that can learn from data to increase the accuracy of the output. With AI, we build systems that can solve complex tasks like a human. With machine learning, we train machines with data to perform specific tasks and deliver accurate results. AI has a wide scope of applications. Machine learning has a limited scope of applications. AI uses technologies in a system so that it mimics human decision-making. Machine learning uses learning algorithms to produce predictive models. AI works with all types of data, structured, semi-structured, unstructured. Machine learning can only use structured and semi-structured data. AI systems use logic and decision trees to learn, to reason, to self-correct. Machine learning systems rely on statistical models to learn and can self-correct when provided with new data. So let's add one more set of letters, NLP. The most visible advances recently have been in what's called natural language processing, a branch of AI focused on how computers can process language like humans. Natural language processing uses machine learning to understand the structure and understand the meaning of text. Natural language processing applications can analyze text and extract information about people, about places, about events. And in doing so, it can do things like understand sentiment, spot trends, derive insights, and classify and categorize things. Until recently, most thought that AI was better than humans at data-driven decision-making tasks, and that it was inferior to humans with cognitive and creative tasks. But in the past 2 years, language-based AI has advanced considerably, and many people have been stunned by what it can do. These advances are most notably represented by systems like ChatGPT, a natural language processing model, and DALL-E, an image generating tool. So now that we've defined our terms, let's get practical and talk about the uses of AI in the publishing process. I'm not going to get into specifics. That's the job of the other presenters. Instead, I'm going to talk about what publishers and editors want from AI. So a few years ago, Highwire held a workshop at Stanford University examining AI in the editorial workflow. 15 publishers and 15 editors participated in that 2-day workshop. I think some of our audience here today may have been there. John Sack, he shared the results of that workshop with me. And so the findings are broken down into 4 categories. Publishers and editors want AI to do things like help them set editorial strategy, help them discover and attract authors, help them handle submitted papers, help them measure and monitor results. The first is editorial strategy. So publishers and editors hope to leverage AI to help shape the scope of their journals and identify the researchers that are making an impact. Key questions that they hope AI can answer include, what is our journal's domain? What are the burgeoning fields, and who are the key players? How can I differentiate between incremental advancements and big leaps in my field? What is the lineage of a paper? What is the relationship to other papers? How do those ideas develop? How are those ideas built upon? And how does that evolution manifest itself in the literature? Who are the promising researchers, and how can I cultivate lasting relationships with them as authors or reviewers or readers? Where are the collaborations taking place? Where is the increasing exchange of methods and techniques across disciplines? The second category is outreach and author prospecting. Publishers and editors are very interested in how AI might make this outreach more targeted and efficient. Things like identifying authors in fields that are not already oversaturated, eliminating authors with conflict of interest from prospecting lists, identifying today's data generators who may be tomorrow's top authors, and understanding the gender and geographical makeup of the author pool and encourage diversity. The third category, handling papers, is all about efficiency in the workflow. Editors want to apply AI to a long list of things, screening submissions to be sure they're in the scope, comparing submissions against previously published papers to assess novelty and impact, determining which papers to transfer to which journals, helping journal staff bridge the gap in subject expertise so that they can do more of the editor's workload, identifying the right reviewer and the right combination of reviewers for each paper, checking the underlying data that is publicly available or accessible, identifying statistical errors, image analysis like image duplication and manipulation, scraping comments from preprint archives to aid in peer review, doing fact-checking statements in the paper, making sure they're linked to the right references, analyzing efficacy of the peer review methods, combating implicit bias, automating the scoring of reviewers based on performance of previously reviewed papers, identifying salami slicers and authors who are just maximizing publications rather than advancing the field. And then the fourth category was all about measuring and monitoring. Most of the available metrics are lagging indicators, which means it can be many months before a publisher knows the reach or impact of content that's being published in their journals. Publishers and editors, they want to look at more reliable, and leading indicators. So they want AI to help, to closely monitor experiments in editorial policies and practices. For example, to determine if authors are becoming more comfortable with the open peer review process, to assess competition in where things like rejected articles are performing well, analyzing the trajectory of citations. Did the papers we publish get cited more often than the papers that those papers cited? Is the journal at the leading edge or the tail end of the idea trajectory? Understanding preprint behavior. How are researchers using preprints, and when in the process are they posting their work? Assessing impact beyond citations, particularly important for clinical papers, in which papers are influencing practitioner guidelines and policies, and differentiation of the rise in submission from hot topics versus the rise of submissions due to special issues or outreach campaigns. So I think the theme you'll see here is that, these are what publishers and editors want regardless of AI, but these are the things that they thought AI could help them with. So now let's get on to what you guys really have come here to see, the presentations from our panelists. I'm not going to go into their detailed bios. I'll just mention that first up we have Joris van Rossum from STM. We then have Ian Mulvaney from the BMJ, and finally we'll have Josh Nicholson of SITE. I do want to remind you that please put your questions in the question box as you think of them, and we'll answer those questions during the discussion portion of the webinar. So with that, I'm going to hand it over to Joris. And please remember to unmute yourself.
Yes, I just unmuted. So if all is well, you see my screen. So thank you, Tony, and thank you for the good overview. I already learned a lot as well today. So I'm with STM. For those who don't know the organization, we are the Global Association of Scientific, Technical, and Medical Publishers. We have about 140 members, from the small academic publishers to the large organizations, and our members are responsible for about 2/3 of all published content worldwide. And our mission is to advance trusted research in collaboration with publishers and other organizations in the research ecosystem. So the topic today is focused on the practical level, but I wanted to start really theoretical to kind of to set the scene. And the observation I want to start with is that we've seen that science has changed fundamentally in the last decades, especially from a small enterprise with scientists knowing each other, collaborating with each other, and corresponding with each other through scientific journals, to a large impersonal and virtual environment with millions of researchers, millions of submissions and publications, and tens of thousands of journals, which led to the situation that often publishers, but also readers of manuscripts, don't know the people behind the manuscripts, have never met them, let alone that they have seen the work, the research actually being done. And that has led to the situation that it made it prone to fraud and manipulation. And that's, of course, what we have seen the last years especially. So it's in that context that you can better understand why something like paper mills could emerge. Again, it is this virtual environment, it is this anonymous environment where often misuse is being made of a ecosystem built on trust. Again, people not knowing each other personally anymore. So last year, STM and COPE published a report on paper mills. Again, paper mills whereby manuscripts are submitted to a journal, and offered for a fee to researchers, and often those articles are completely fake and manipulated. led to a lot of retractions as well. And it's really, I would say, one of the main challenges for the academic community at the moment to solve that challenge. And it's a big focus for STM as well. So again, it is this virtual anonymous environment that led to the possibility of paper mills. But then, of course, came generative AI a few months ago, which made things potentially even worse. And I just came across this tweet last week, and it really inspired me. In the end, nothing can be trusted online because of AI. Well, that is potentially indeed the case, that the potential for fraud and manipulation only became larger with AI. And again, became a big threat for publishers and the larger academic community. And that's what I want to focus my talk on today. So how do we deal with this, and how can AI form a threat, but also how can we use AI to prevent this from happening? Now, AI, of course, is not new, and Tony gave a good overview of all the things that are at least desired by publishers in terms of using AI. And the relation of publishers with AI goes back a long time. First of all, we are, of course, excellent providers for content. Good structured content is essential for good AI. Garbage in, garbage out, and of course, publishers with their experience in quality control and peer review are excellent providers for AI data. AI is also increasingly being used to support internal workflows and services. And Tony, you gave a very good overview in terms of quality assurance, reproducibility checks, creating taxonomies, content enhancement, and of course also language improvement of manuscripts. Post-submission, AI plays a big role. And also publishers have been developing externally facing tools and services and making use of AI. And this is an overview of 2 years ago. 2 years ago also, with already then the rise of use of AI and machine learning in the academic community, STM produced a report, a best practice principles overview, where we laid down various principles for an ethical and trustworthy AI, and you can easily download that report. It's free. So our principles were grouped around several. First one around transparency and accountability. Very important that once AI is used, that we need to be transparent and accountable for that in terms of the data used as inputs, but also for training. And especially when AI is used as a decision tool, it is important that publishers are very transparent about that use. Quality and integrity is another set of principles that we defined in the report. Really at the heart of the AI life cycle, from the design and building of algorithms, quality should be really perhaps most important principle there. We also developed several principles that focus around data protection, data privacy, and security, essential to AI as well. And last but not least, we really have to think about fairness when we talk about AI. AI being based on identifying patterns and in existing data, and it holds the risk of historical bias. And of course, a lot has been published and discussed about the results in terms of discrimination, and also the preventing of novel ideas and theories entering the scholarly ecosystem. So also an important principle to take into account when we apply AI in our work, in our processes, and in the academic ecosystem in general. But again, this was published 2 years ago. We're probably looking for an update for that report this year as well. But then, of course, came a ChatGPT, which is really probably a fundamental change and a game changer. As Tony mentioned, NLP is excellent. It can understand a human language in an astonishing way. It can process an enormous corpus of information that no human can ever do. And even more impressively, it can produce text, and with GPT-4, they say even better than humans themselves can do. So this will have a fundamental impact, not just, of course, on publishers and science, but on education in general. We at STM, we had a conference, we organized a webinar ourselves a few weeks ago, and there was a teacher from a university, and they are even affected more fundamentally than we are as publishers. So really big changes coming our way. And going back to the theme I started with, the challenges we had already with dealing with a virtual environment where we don't know each other anymore, an environment that became more global also the last decades. So how can we establish real science in a virtual environment? And that is really, I think, one of the big challenges that we have. How can we make sure that the science that we report on, we publish on, is real? How can we even establish that the people that are submitting the manuscripts are real? Again, a challenge that became larger with AI, and especially with generative AI on the level of text, but also images that we have seen the last month. This is an issue. So again, how to distinguish the reality behind the virtual nature of our work. But it's not the only issue that AI raises. Of course, a few weeks after the release of ChatGPT 3, we've seen the first publications with GPT as the authorship. That was an interesting experiment that led to a lot of news coverage, but many publishers have developed their policy since then, and most of them agree that this is not the way to deal with authorship. And I would say the general consensus now among publishers is that yes, that ChatGPT and other language models can be used, but if it's used, it should be accounted for and clearly stated at the submission. Another big issue that AI raises, and especially now with generative AI, is the whole copyright issue. And yesterday I spoke with somebody who explained the metaphor of a coffee machine. Good coffee, you need two things: beans and a grinder, and a coffee machine itself. Well, AI might be the coffee machine, but you only can get good coffee by the beans, and it's humans and it's publishers that produce that bean. So how do we deal with it? We're basically faced with a technology that uses up all the knowledge ever produced by human beings and providing that back. And we have to really fundamentally think about the terms and conditions for using that knowledge, and something that that's already happening, especially in the creative industry the last weeks. So interesting developments. But let me go back to the main challenge. This is around research integrity. And here it's interesting to note that AI and fake science, it's really that AI is a double-edged sword in relation to fake science and research integrity. Because on the one hand, we use AI to identify fake science. Plagiarism tools, of course, being in the market for many years, making use of artificial intelligence. So on the one hand, we use AI to screen manuscripts and reject those that are that have issues. But of course, increasingly, we see that AI is used to create fake articles, text, images, data. I have been experimenting with several tools that claim to be able to identify if a paper is created by GPT. I myself are a bit pessimistic about it. I don't think there is a tool that can do it. And even with the new models, some even say it will be impossible. So it's a huge challenge. And it's an arms race we're in. So on one hand, it's we use it, and on the other hand, bad actors are using it, and we'll see where that ends. And I'll end my talk with a prediction around that. In any case, what we need to do is to collaborate in order to combat these developments and the potential of AI in this challenging environment already. We have to work together, and that's only that need is only accelerated with the developments in the last month. Again, AI requires that we join our forces. It's a big challenge. It's a big opportunity, but also a big challenge, which requires us to collaborate. But there are more reasons why publishers decided to collaborate on the level of research integrity. Also, more and more solutions need a joint, more and more problems need a joint solution. think, for example, about duplicate submissions. That is, paper mills often make use of duplicate submissions, so they send their manuscript to multiple journals in the hope that one of them will accept them. This, of course, can only be discovered if publishers work together. If there is a system whereby multiple submission streams can be screened, it's only in that way that you can identify duplicate submissions. Building large training corpuses is also essential for AI. So for us as publishers, to be able to spot and identify fake research, we need to build those training corpuses. And again, also there, we need to work together. But also we've seen that many publishers have started to develop their own screening tools, their own tools for screening, for example, compromised images or data. And publishers are often willing to share that. So the Integrity Hub, the initiative that we started in response to this, also allows tools developed with one publisher to be shared with other publishers. Collaboration is needed also to develop legal and policy frameworks. Our system is a system built on trust. We see that trust being threatened by bad actors, but we want to ensure that whatever we do with our processes are based on ethical behavior, on confidentiality, etc. So in order for that, and in order to incorporate something fundamental as AI, we need to work together to work on the appropriate policies. And last not least, why we collaborate in the Integrity Hub is that we want to make sure that there is no advantage for larger publishers who often have the tools and the capabilities and the manpower to build screening tools, to have large integrity teams. We want to make sure that the smaller publishers have the same opportunities. So make sure that whatever experience, whatever knowledge, whatever technology we build, that is equally offered to the smaller ones, so that the paper mills do not target, let's say, the smaller publishers only. So we want to ensure that whatever we develop as a community is equally distributed and offered to all publishers in the entire ecosystem. So this is why we started the Integrity Hub. So we initiated this last year in December 2021, so 1.5 years ago. And our mission is to equip the scholarly communication community with data, intelligence, and technology to protect research integrity. Again, to a large extent, driven by the challenges we see in light of paper mills, but became even more relevant now with ChatGPT and other generative AI seen in the last month. How do we do that? On 3 levels. We share knowledge and intelligence. We publishers, we are quite siloed by tradition, but only by sharing the experience, sharing the data around paper mills is already very effective. We create policies and frameworks together. And last but not least, we built an enabling infrastructure allowing incoming manuscripts to be screened for various issues. So to prevent paper mill material, but other compromised material to enter the scholarly records. We want to make sure that we screen that at submission, and meaning it doesn't enter the peer review process, let alone the scholarly record, which requires it to be retracted. And that is a very painful, of course, and lengthy process. So the Integrity Hub is all about collaboration, and you've seen some of the publishers that are part of that hub in the last slide, but we also work with many specialists and external organizations. Of course, many specialists have developed really good tools. You see some of them, Jennifer Byrne and Guillaume Cabanach. We incorporate that as well. So we work as a community really with these sleuths, with these specialists, to ensure that we can harness that, that intelligence and that experience and apply that to the submission process. I'm going to skip this. This is just a very high level of the infrastructure. So how do we make sure that the incoming manuscript can be screened in a safe way? Again, essential is that all our standards around confidentiality and privacy are safeguarded, and this is the high-level overview of the infrastructure that aims to do that. And I'll just tell you a few things about the latest status. So where are we now? And I'm just going to focus on the technology here. So last week, we launched the MVP for what we call a paper mill checking tool. Again, what we would like to do is ensure that all the tools, all the services that have been built in the last years by publishers, but also by organizations like PubPeer and Clear Skies, that we make them available to submission phase. Publishers can upload incoming manuscripts, several tools. We have now 7, 8 tools incorporated. So if there is any suspicious pattern that we find in, for example, the text or in the reference list, or if there is, let's say, a fake domain being used, then there is an alarm. There will be, also very important principle here, it's never AI, it's never technology that makes a decision, but what the technology does here is provide information to the integrity manager or to the editor saying, we found something suspicious, this could indicate a paper mill or another problem, please check further. So this is what we launched last week. It's an MVP, incorporating around 8 signals now, but we are, of course, busy with extending that and testing this. And another important tool we are developing is a duplicate submission checking tool. We aim to start this pilot in the next 2 weeks, and it's the first time where, again, incoming manuscripts over different journals, publishers, but also submission systems can be checked. So if there is a manuscript that is submitted to multiple journals at the same time, which is of course not allowed, but also more importantly, often indicative of paper mills, then a signal is sent to the involved editors, integrity managers, who can then take action, follow up, and reject if needed. So this is how we apply technology in a broad sense, but also specific AI technology in our efforts to prevent paper mill material, but also other material compromised to the scholarly records. And I just wanted to leave my talk with a thought. And again, I mentioned the arms race. We use AI, but also the bad actors and the paper mill use AI. This is a quote from Elizabeth Bick in the interview in the Financial Times last week, who said, AI will likely be used to generate realistic text, data sets, and photographs, and it will be much more harder to detect these papers. This is also, well, I would say a fear, but I think this is going to be a huge challenge. When you look, for example, at image manipulation screening tools, they often are based on the fact that images are often copied or manipulated. Well, if you can use AI to just come up with a totally new image or a totally unique data set, it will be very, very hard to detect that. The same as it is very hard already to detect AI-generated text. So how do we deal with that? Well, of course, the Integrity Hub, of course, the paper mill screening tool, we'll further elaborate that and include it in new tools, but perhaps also we have to look a bit beyond AI and beyond the manuscript. So maybe in the future, we have indeed, whenever there is a manuscript being submitted to a journal, maybe there is some kind of chain of custody, some proof of the research that went into it. Again, ensuring that we understand the reality behind the virtual nature of our work. Maybe we have to do more about identity screening. So maybe we have to get a bit more knowledge about the person submitting the manuscript and understand and verify in a better who that person is. But also maybe we should look at trust markers. ORCID started a project recently on trust markers, whereby institutions can verify individual researchers, which again would also make sure of an existing ecosystem and bringing more trust in the submission process by allowing research to be verified and endorsed by institutions. So again, possible extensions of our work to understand better the reality behind science. So that's it. Thank you very much. This is my presentation. Next week, there is going to be a whole week, especially a whole day, the Research Integrity Masterclass. It is in a few days already, but if you're interested, please feel free to join us in Washington next week. And I thank you for the attention and look forward to your questions.
Thank you, yours. Thank you very much. I'm looking forward to next week. That's going to be a lot of fun. So up next is Ian Mulvaney from BMJ.
Thank you very much, Tony. Let's see. All right, are my slides visible?
Yes, they are.
Okay, thank you. So I'm going to talk more broadly about how we at BMJ are using AI in a number of different areas. And actually probably thinking less about AI itself and more about the kinds of capabilities it can give you. So aside from how it works, I think there are two things you should be asking yourself. Can it help you do something faster than you can do today through a different method? Or does it provide some kind of state change and create an entirely new kind of capability, making something that was very difficult so that you wouldn't do it before possible today? And so even if you ignore the machine learning aspect or the AI aspect, it's these capabilities that brings to the table around product innovation. And I think those are the things you should be thinking about. And with those capabilities in mind, the other thing I want you to think about is, what is your moat? And by which I mean, when you're thinking about how you're creating value in your market, what are the things that you're doing that are providing unique value to you or unique value to your customers, to help you try and decide where you should be putting your bets around how to work with these technologies or implement them. And I think as well, partnership will become a key theme of what I'm going to be talking about today. So when I talk about, I titled this talk, Bending the Curve on Product Innovation. So I want to talk a little bit about this. This is kind of a life cycle of a product. It starts off early, few customers, then it goes through a growth phase, then you got a phase of maturity, and ultimately products tend to decline in the end. And so over the period and life cycle of a product, and hopefully you've got a number of products in your product basket, there'll be different phases of evolution. And quite a lot of ideas that you start with, this is a related curve, but not exactly the same, start off as nice new ideas initially, but they fail to get widespread adoption and they just die at that left-hand side of this curve. And so what that tells us is what we should be doing is making lots of small bets down here on the left-hand side, down here, because and try to make these bets as cheap as possible, because many of these are going to die. This is where most of your revenue is going to be. That you've hit market product fit. The idea here is to try and optimize cost as much as possible, and then invest here, because this is an area where there's still potentially market growth. And so again, the key thing here is there's lots of excitement here because you're doing lots of innovative stuff, but revenues generally tend to be tiny. Up here in a settled area of your product portfolio, probably revenue's good, but you've scaled your systems already. So making radical changes in that area, in changing markets or new environments is costly, because there's a lot of baked in process. And so when I talk about changing the curve on the product innovation curve, the question is, does AI give us capabilities that allow us to bring more bets to play here that we couldn't have done before? Or are there things that we can do that can extend the life cycle of where most of our revenue is coming from? So that's kind of what I want to think about. And I'm going to give some examples across this curve of what we've done at BMJ. So the first example, and a lot of this was through partnership. We partnered with a company that did aggregation of information across a vast number of sources to see if we could build custom dashboards for particular types of diseases. And this was on the back of the COVID pandemic, when lots of people were trying to bring these dashboards together. And the technology worked, but we couldn't find a buyer for this, because it was a nice to have, but not a need to have. So it was a good example of an idea that we were able to bring to test in market quickly, but it didn't work because it wasn't creating any value to the point that anyone was willing to pay for it. So it was an idea that we ultimately had to kill. Another idea that we've worked on in this kind of segment of this product lifecycle is one that we worked on in collaboration with Overton and you and Addy around trying to assess research impact. And we co-developed a version of Ewan's product with paying customers directly in mind to help research managers and funders identify the impact that their research was having in clinical research and how that was being referenced and cited in policy documents. And actually, this has been successful. We have found buyers in the market and we found a lot of interest, and we're building a nice pipeline on this. So that's an example of trying to think about what that moat is that you have, where you're creating value. But what AI has done in both cases through partnership has allowed us to prototype new capabilities that we wouldn't have had before to get more bets going at that type of point of the product lifecycle. One area that we're doing a lot of investment in, we have a product called Best Practice, which is a clinical decision tool to help doctors in secondary care diagnose patients and understand the best clinical recommendation for how to treat those patients. And we are investing heavily in this area to create a knowledge graph on top of the data that we're producing. And so we have a classic editorial workflow of curating clinical guidelines as they come out. But we think that this is an area where the cost of creating high quality, high trusted data is so high, it's very difficult to displace that activity. But if we can make that information more computationally effective, we can find new markets for that information. And so our moat is how difficult it is to curate and verify the trustworthiness of the information, and the opportunity we see is making that data be more operable in multiple systems by investing in the tagging of that data and making it more computationally usable. One of the big challenges we have is in this area around our journals and our journals portfolio. Journals are where most of our revenue comes from, and our systems here are old. We're on legacy systems. We have lots of embedded process. We have lots of manual processes. They've already been very well optimized for cost, so there isn't an appetite for an enormous amount of investment in this area. And yet it's one that has huge amounts of potential from the kinds of technologies that Joris and Tony were talking about. So how do we get there? And this is just a quick overview of some recent work we've done looking at the challenges and opportunities around this. And this is probably very similar to a lot of publishers. And just to put that in context, Springer Nature in 2021 invested 120 million euro in their publishing systems to try and get them to scale. Now, we don't have the ability to do that at BMJ because that's way more than the kind of capital investment we can make. So for us, it's going to be key to understand who we can partner with that can help bring some of these innovations into this area. But I think this is going to be one of the harder areas because some of our existing systems and workflows are so embedded in the processes that are already extant in the organization. And so it's very easy to do innovation at the left-hand side of that curve, where you can spin out some ideas very quickly. But where most of your revenue is, I feel it's actually going to be quite hard and quite a challenge for a lot of organizations in our industry to apply these technologies there. So we're going to need to depend on work like the work from the STM Integrity Hub, work with integrators, work with partners in this space to be able to realize these benefits. So on ChatGPT, I just have a few comments. It's like Yara said, it's a bit of a step change in the kind of technology that's available from these systems. So it's almost like Prometheus has come down and granted us an entirely new power, and we don't really know what's going to happen with this over the next couple of years. There's a really good talk by Benedict Evans where he talks about technology S-curves, and we come into beginning to interact with these large language models now with maybe some of the biases that we've had around how our technology works today. And Benedict Evans talks about the mobile transformation that happened with mobile phones, and when mobile phones started to gain adoption, people thought that the things that would be transformed with mobile phones would be people doing e-weather or email on the go, but actually the mobile phone disrupted transportation industries, disrupted the taxi industry, disrupted delivery. It disrupted so many more things at the end that we hadn't thought about at the beginning. And we're at that phase of just entering this new S-curve. And some people predict pretty terrible things about these large language models, that they could lead to quite bad outcomes. But hopefully we won't experience some of that. But I think one interesting way to think about it is at the moment there are a lot of risks to the kinds of work that is highly grammatical and highly predictable. So research work is not in this domain because research is not predictable, but the outputs of research do look predictable because the formats of papers look so similar. So the sad thing is these tools will be able to create fake papers, but maybe won't be able to help us do pure research. That still will require humans. But there are a lot of other things that we do as humans that these tools will be able to realistically augment and maybe even displace. And so I think that's something we need to keep an eye on as an industry. So just as an example, one of the software engineers in one of my teams, Daniel, is now using one of these tools and Copilot. He's using it every day to write code and tests and documentation, and it's become an integral part of his development workflow. And he feels it's speeded up his productivity by about a factor of 2. And so there are ways to optimize what we do by applying these tools if we can find the right use cases in our workflows to do so. And this is just an example of some documentation that was auto-generated by some of the tools that Daniel's using almost instantly, which is very appealing. Finally, I think these large language models will help us make more bets faster. So just as a couple of examples, we're experimenting with whether these large language models can write exam question content for one of our products for us. We're seeing if it can enhance our ability to tag our content. We're seeing if it can help us speed up our ability to prototype UIs and test those ideas faster. So I think there's a lot of applicability for these technologies across that product development curve. But these models have only been around for really 4 months as we currently understand them. So we're going to go through considerable period of really radical change, I think, over the next year or two. It's going to be very interesting to see what happens. Okay, and that is my talk. So I'm going to stop sharing.
Awesome. Thanks for those 2 amazing talks. I really liked kind of the interactivity, and I think they're nice complements to what I'll be talking about, which is a bit more practical and kind of application focused. And so I want to talk a little bit about how research publications in general can provide some quality control to this beast, if you will, this ChatGPT and AI in general. And if you think about it, this is not kind of the first time that research and scholarly publishing has given guidance to this problem, right? And so, with the advent of the web and Google and these search engines, there was a need to rank web pages, right? And PageRank and really kind of what separated Google from other search engines found direct influence from citations, scholarly citations. And I think that's kind of something that is going to occur in our field. And so, we have as Tony mentioned, really focused for years, hundreds of years in many cases, on producing relevant content. And so I like to first kind of start very optimistically, and I'll just remind us that there are these challenges with paper mills and copyright and submissions and et cetera. But behind all of this is really amazing stuff, right? Research impacts nearly everything you can think of. I often say that, we have research on Peppa Pig, prostate cancer, and particle physics. And it's really fun to kind of try and think where there is not research and try and search for that. And undoubtedly, someone has spent maybe half a decade of their life doing deep, intense research on a subject. And so this is something we're celebrating. We're, really taking some care around to make sure, that integrity is maintained so we can continue to build these amazing things, continue to inform our lives. in a better way. And that's owed to publishers, to researchers, to editors, to peer reviewers. It's a complex ecosystem, and I think it's something that we should be proud of. With that said, and this is something that we've been thinking about for a while, even before kind of AI. How do we know what to trust, right? And so around the end of my PhD back in 2012, 2014, there's growing concerns around reproducibility. This was not reproducibility as it relates to AI, but reproducibility as it relates to, can we validate what humans are doing themselves? And so, we at Cite, which I'll talk a little bit about in a second, have been thinking about kind of, how can we trust, how can we verify, how can we validate, how can we trust research itself, right? And I think what our focus has been on for almost half a decade at this point has been making it easy to kind of see how any topic or paper has been cited to help with better understanding. And so that is kind of the focus of Cite. And as the name suggests, we are focused on introducing the next generation of citations, which I think can really help with information literacy, validation, and things like this beyond just metrics. And I think citations have somewhat lost their way in that they're used superficially, they're used for rankings, they're kind of hated by a lot of people. And so, we built Cite and really focused on citations to make research more reliable. And I think our applications, looking at research in general, are going to have, a big impact on generative AI as well. We built it also to make research more understandable. And so it's not just accessibility. Can I read this PDF, but can I actually understand it? Can I utilize this research? It's becoming increasingly interdisciplinary. Yes, there are many and many authors on a paper. Oftentimes you have never met these people. And so can I trust it? Can I understand it? And then, I'd say the aim that we have now is to kind of introduce these next generation of citations. Again, something that I think, is a core part of organizing massive amounts of information, whether that's research articles or kind of the web as a whole. And so just to make sure, we're all on the same page of what a next generation citation is, I like to quickly show the world as it exists without Cite, and then to show it through the lens of Cite. And so this is the main study coming out of my PhD. When you look at a research paper, you naturally look at a few kind of heuristics and proxies of quality. Where is it published? Who are the authors? What are their affiliations? And then some metrics. And I would say, we all will make different judgments based on our experience with this. Maybe we have a different view of eLife now than we did 5 years ago. Maybe it's better, maybe it's worse. It kind of depends upon how you perceive these things. Our focus is really on, as the name suggests, citations, right? And so in today's world, and for decades, citation indices have primarily just shown a list of citing articles. There is, many reasons to cite an article. You can cite it in the introduction section, you can cite it in the methods section, you can cite it 5 times throughout your article, you can cite it just once. But in today's world, we kind of treat them as if they're all the same, right? And so to see what these 66 documents have said about my study or about studies in general would require you to open 66 separate documents just to look at how one individual article has been cited. And so if you're talking about tens of articles or maybe hundreds of articles, you're potentially talking about hundreds or thousands or hundreds of thousands of citations. And so we're boiling down this very valuable information, directly related information, into single numbers and just kind of utilizing it as high as good, low as not so good. But maybe behind some of these are core pieces of information that can help you better trust or distrust this paper. And that's what we want to do, is to kind of surface this information by showing the context. So if you look at my article through the lens of Cite, what you do see is a list of citing articles, but crucially, and quite unique to what we do, we're showing the citation context. And so we're going into the full text of articles through partnerships with major publishers, extracting out the in-text citation mentions so you can quickly read how are these papers discussing one another. Right. And so this paper, published 3 years after mine, cites my work in the results section. And here's how they cite it. They say, in agreement with previous work, and then cite Nicholson et al. The trisoma clone showed similar aberrations, albeit to a lesser extent, supplemental figure S2B. This paper itself has been cited 32 times and then received 4 supporting citations that would look something like this. And so this is kind of this core unit that we've been focused on developing for some years, is really showing this contextual information that allows you to see how a researcher has been cited, how a research paper has been cited, a journal, a university, even a topic, right? Because we now make it possible to search through these 1.2 billion citation statements to see how has topic X been discussed in the literature, and where is there criticisms, where is there supporting evidence, et cetera. And so this, requires cooperation, right? Publishers sit on what I would say is kind of the closest thing we have to verifiable truth in the world, right? It's not perfect, but there is evidence, there's analyses, there's peer review that's been done. I don't think there's anything really kind of better than what publishers are producing, at least, that is publicly available. And so we spent years partnering with publishers to get access to the full text of scholarly articles so that we can extract out this information and then present it, alongside the version of record. And so we are Cite.ai, and we've been AI for a while now, because we are doing some machine learning to extract out this information. And so yes, there is some nice structure into papers, but it's also quite challenging to extract out this information, because you're talking about thousands of different reference styles, a lot of different formatting styles across PDFs, and going into PDFs, which most content still is in, especially pre-2000, is difficult. And so we utilize a lot of machine learning to go in and extract out this information. And this is a visual representation of what this looks like. And so you have to identify that in-text citation, correctly match that in-text citation to the reference in the reference section, which again is going to have variable information. Take that string of text and then match that against metadata from a source like Crossref or DataCite. And so we have been using AI for a while. Other tools are also using Gravid, which is this open source tool that we use to extract out this information. We have gone a step further and are seeking to classify the text around that in-text citation to try to indicate if they're supporting or contrasting evidence to the claim. And again, we have used some deep learning here to do that. And that has, really kind of been made possible with a lot of these advances that we've seen in AI in general, or in machine learning, where these deep learning models you can almost kind of use off the shelf if you have a good training data set. And I think, of course, it'd be amazing if humans all classify their citations, and in some senses they are by writing the sentence. But to look at billions of sentences in scholarly articles, really requires some automation. And so, we have published a paper on this that describes really kind of the details of building sites, the deep learning that we're doing, the precision, the recall scores, really kind of everything that you might need to look under the hood. And I'm happy to say that this is not just kind of at the early curve of what Ian showed, right? It's no longer just a concept that maybe will work, right? This is starting to be adopted now by millions of articles. Some of these traditional citation indices are starting to follow us. And I think what we're starting to see is more nuance around the citations. And I think this will evolve as well. I could imagine, and hopefully there's some publishers on this call, showing some of these citation statements natively. So not just showing 3 numbers, but even showing some of that context from their own publications natively to see what is this conversation happening amongst papers. And so this is starting to be rolled out across papers. Most are showing by types, but you can show by sections. And yes, we can also show citation statements natively as well to improve this. And so we have been focused on citations and making it easy to see how scholarly articles, have been cited, if they've been supported, challenged, et cetera. And then in comes the world of ChatGPT, large language models, and generative AI. And so, we didn't start Cite because we wanted to do anything with ChatGPT. We didn't even have such a consideration that this might exist when we started it. But, as people have experienced the power of ChatGPT, and I do think it's exceedingly powerful, it's very easy to use. It can also be wildly wrong, right? And so the way it works, is not to kind of give you facts, right? Is, giving you this predictive outcome, and doing the best it can with how it's been designed. And so people have naturally tried this in the research domain, and what they found is that ChatGPT will, give answers that can sometimes be very right, but sometimes they can be very wrong, and they'll ask for references for these things. And these references again, look very right? There's, real author names often, there's pretty sensical titles, there's even DOIs, right? But these DOIs don't resolve, these articles are often made up, and that trust has quickly kind of evaporated from the research community, because they say, yes, this is great, but when you're making medical decisions or you're making really kind of critical decisions that might affect your own research or grant or something like this, you need a way to trust this output. And so I think, we have said, okay, here we are, this small group of researchers focused on citations, and what does ChatGPT really need? Well, it needs citations, right? And I think that's going to become equally true of the large language model area, just as it was of Wikipedia, right? And so citations are now kind of becoming sexy in a way. You see them on Bing. Google's going to start to show more of these citations. And I think we're, as a scholarly publishing community and research community, we have been focused on citations. That's a great thing about, scholarly articles, is that you need to provide citations for these sources and these claims that you're making in them. And that's not always true of the web pages. And so, we're now starting to see that ChatGPT is creating fake references, and there's so early on that, how this is going to play out, is probably going to change from week to week as more and more tools come out and more approaches come out, and more things that we find. And so what have we done, right? And so what we have done is to say, hey, in partnership with, major publishers, we've created these quote unquote next generation citations. In comes this large language model. How can we kind of combine the two? And so what we're doing, and this is about 2 weeks old, maybe a bit less, is validating ChatGPT output against the full text of research articles. And so we've launched something that we call Assistant. Assistant utilizes ChatGPT's API. So you can ask a question, or really kind of any type of question, just like you can ChatGPT. This can be how many rats live in NYC, and you can see I have some influence here, which is where I'm based. These can be very specific questions around proteins, genes. They can also be around policy. And what it will do is take this output of ChatGPT and then match that semantically against our database of citation statements and abstracts. And if you look at citation statements, they almost make up a full text article to kind of say, hey, you need a reference for that. You need a citation for that. And if we can't find a reference for this output, that sentence is generally tossed, right? So we're really trying to reduce hallucinations, provide real references, and give a way for you to verify what the machine says and what the scholarly articles say. And so what does that look like, right? So here is an example of a user testing this out that asks, what is the relationship between sunlight exposure and serotonin levels in humans? And so you can run powerful Boolean queries in search, and I think that is amazing, and I believe that will continue on. But there's also power to running these kind of natural language queries where I have a question, I just want to know what is the response. And so if you ask this, you will get this output, and this output might look quite similar to ChatGPT, but what is different here is that we're providing these references, these citations, to scholarly articles. And so you can hover over the references or click them, and you'll see what the article says directly, that paragraph from the full text of the article or the abstract, and then see what has been generated from the AI. And so it makes it a bit easier to kind of verify and validate this output against the literature. And it's not perfect, but I do think, by focusing on citations, we have kind of an ability to find a peer-reviewed article that has data, evidence, analysis behind it. And then we also have a system that allows you to see how that source itself has been cited, right? And so here is one, write a paragraph on how video games influence spatial reasoning. Gives you this reference. Okay, that reference is not necessarily fact itself, but you can see this paper has been highly cited. It has 54 supporting citations and 9 contrasting citations. You can then, again, go look at these citations and see, how has this been cited, and do I trust this? Do I no longer trust this, et cetera? And so I think, research articles in general are a great source of kind of quote unquote truth, or as close as we can get to it, that can be this kind of counterweight to this generative text. And I think we've, shown one application of this, and I think it'll continue to kind of evolve around that. But the system of citations, peer review, and validating and actually having data and evidence and analysis beyond just people's input is something that is important. And I think what is also interesting is that, these groups with these large language models are scraping a lot of the web, but they're also not touching a lot of publisher content. And I think that's going to become increasingly important and interesting for this space, which is, okay, we're utilizing, all of the web and all of open access content. What about the content that's not open access? Or as we go to this open access world, how does that influence these large language models and things like this? And so I'll end with a question that, has this time been beneficial? And of course, you can make up, your mind on that yourself. But I think, how I see it is, yes, there's massive dangers in AI. And I've already been tricked by some of these images with the Pope wearing this big puffer jacket and things like this. But I also think there's huge advantages, right? And it's not as black or white as we must ban it or we must only promote it. There's going to be a lot of nuance, a lot of kind of battles with this double-edged sword, and a lot of learning, I think. And I think the scholarly community has a lot of lessons to kind of share there that was really informative for the web and how that really kind of gained traction. And I think, again, will be very informative for generative AI and how this is going to get traction as well. And so thanks everyone for attending, and also thanks to the other presenters. They're really great talks. And I'm happy to present our work on this space.
Thank you very much, Josh, and really thank you everybody for that, for each of those presentations. I think I certainly learned quite a bit. I'm having a little trouble finding my there we go. I had a little trouble finding the webinar. So again, thanks for that. We have several questions that have come in over the course of the talk. I'm going to just bring up one slide here. And it seems like a lot of the questions came up around things like copyright and ownership of information and content, which isn't surprising because we have a group of publishers and editors and people like that, librarians and researchers who care quite a bit about that topic. So some of those questions, when scholarly unaccepted manuscripts, unpublished data, or peer review comments are input into systems like GPT-4, are there privacy, legal, and ethical issues? Who owns the output if a manuscript is uploaded into GPT-4 for editing? Questions around court cases about generating images from AI. I want to preface that none of us are lawyers, I don't think. If any of you are lawyers, you feel free to speak up. But Joris, do you want to take any of those themed questions?
Yeah, unfortunately, I'm not a lawyer either, but I think that these are very good questions. I don't have the answers. I think indeed there are three levels of questions around copyright, and maybe Josh or Ian have more answers. First is indeed, how does ChatGPT deal with all the content that they scraped? I think that is an issue that's coming up, and a fundamental question, as I mentioned in my talk. Then is the question, what happens with the input? So when you type something in ChatGPT, so we don't use it in our system, so I wouldn't know. But I do know that once we are using external systems, we have agreements around confidentiality, the use of that content, etc. I'm not sure how that happens with the API, but maybe Josh does. In terms of output, what I understand is that it's not copyrightable, whatever comes out of ChatGPT, because it's not the intellectual of a human being. I think that is the definition, at least in the US, for anything being copyrightable. I do know there are big discussions around the code. I heard your story, Ian. Many programmers are now using ChatGPT to generate code, and I know there are many issues around ownership there. But that's all, as I'm afraid, as far as my legal knowledge goes.
So Ian, yeah.
Okay, so when you're interacting with these large language models, I think it's very important to understand what they are and what they're not. They are not, you should not think about them as search engines. They have used a large volume of natural text to encode a comprehensibility about text. And so you can use them to ask questions like, summarize this text I have, or rewrite this thing in this other style. But they synthesize this large volume of training data and are not reliable interlocutors to ask questions of. So don't treat them in that way. The models are running on systems that are outside of our control or our domain. So any information that you put into them, you have to treat and assume that that information is not secure and not safe. You also have to be aware that it's possible that there could be intercepts between your query and the engine that could involve prompt injection. And so the response you get back might not be the kind of response you're expecting to get back. So these are all vectors of risk. But one of the things that's really interesting about these models is there are increasingly capable models that are coming to market that are smaller and can be run privately, can be run in the browser, or can be run in domains where we can have more control of them. And so that's an area that I think we'll need to pay attention to over the next few months. That said, asking those grammatical skills, those language skills, that can be applied to many of the types of work or tasks that we take on, and there's a lot of benefit there. In terms of the code question in particular, yeah, I get that there's issues around copyright, but many software developers up until now have used Stack Overflow extensively. When you think about code, 98% of the code any developer writes has already been written before. They're just rewriting it. And so irrespective of the fact that these things may be trained on highly grammatical structures, I don't think that's going to prevent people from using them, because the facility they provide and the speed of productivity they provide is so high. I spent about 40 minutes this morning writing an extension to Safari to help me cut and paste links to browser tabs. I'd never written a Safari extension before in my life, and I got it up and running. And now it saves me time in copying links to tabs that I'd opened, because I was just interested to see if it was possible. In the last 2 weeks, I've written 2 web apps using technologies that I've never used before. It's just dramatic how much more effective these tools can make you in those domains. It's really, really interesting.
Josh, you're directly involved in working with this. Do you have any insight?
Yeah, I mean, I don't have much to offer around, like, you know, what it's kind of a broad question, but I think to pick up on the last point, right? You know, this is not just about like kind of making it easier for, you know, English as your first language to be better, faster, right? I think there's like a great equalizer here, right? Whereas English as a second language, you know, this helps a lot for communication around the world. And that has been something that has been very powerful. And that I think, you know, the web was a great kind of equalizer as well. You know, people stopped caring less about, this is maybe going to get me in trouble, less about journals when PubMed was there. Because, you know, if it was in PubMed, you would find it regardless of kind of the journal name. And I think, you know, there is still papers being rejected for, oh, your English is not good, the grammar is not good. You know, people are paying a lot of money for this. And I think we're probably losing out on very good ideas and perspectives for that simple reason. And so I think there's a big positive aspect around that as well. And of course, yes, all these things are scary, right? Is there going to be sued? Is it going to take my stuff? But this is true of like social media and the web in general, right? And so it's not anything necessarily new. You know, I saw one question that I think Ian answered to is like, okay, you've had Grammarly before, you know, large language models as well. This is looking at everything you've ever written in your emails. And so, we always kind of get scared at these big things. Is it going to take this? But, also at the end of the day, as a researcher, you're willingly giving up your copyright to publishers also. And so I think, yes, we should be concerned about privacy and about these things, but we shouldn't let it like be this dark cloud that we don't utilize any of these powerful features that it offers. And I also don't think it's going away, right? And so this idea of just blocking it and kind of banning it from certain systems is in my opinion a bit short-sighted. And I think we'll have to like recognize it's here to stay. It's going to permeate this. How can we better interact with it beyond just outlawing it? And yeah.
Ian?
Joris was first, and then I'll
Oh, I'm
Yeah,
sorry.
I
You're
did
right.
it in a proper way. So so thanks. First, George, thank you for telling me about the jacket and the Pope, because I didn't understand it was fake. So that's good to know. I just wanted to, on the positive side, what Ian mentioned, I think there is a huge potential to fundamentally change the way researchers search for content now. I mean, your query in a large database of scientific content, getting results back. I think indeed, if we can apply the technology over a corpus of scientific information and having the, asking a question and getting a narrative back, I think that is a huge potential. I think definitely something we have to explore as publishers.
So if you interact with the raw models, they can be highly unreliable, but they are going to be deployed in many domains that will have a higher bar of requirement around fidelity. And there is a huge opportunity for us in our industry to play a positive role there. And so there are lots of methods for taking these models and making them work in a more reliable way. And so there you need highly validated information and highly validated data. And that's what we do. And so I think there's an enormous opportunity in being an active participant in how these technologies get deployed in society and how we can help the implementers of these technologies source highly validated corpora of information, how you get them to interact with validated databases, how you bring to bear validated evidence to the answers that people are getting out of these systems, even more so than before. So it's a huge, I believe it's a huge opportunity. Yeah.
So I think following a similar theme where, we need to be sure that the questions that are being answered by AI are truthful and are cited. Doesn't that require sort of open and free access to all of the information that's out there? That when the information is behind a paywall, does that mean that questions around that information might not be available for confirmation or fact checking by some of these tools? I mean, how do we ensure that these tools are able to access all the truths, I guess is the question I'm getting at.
Yeah, I think that, so the history of OpenAI is an interesting one, because it started as a non-profit and the idea was to have everything entirely open AI. It turned into a commercial company and now it's not open anymore. We don't have any knowledge about the algorithms. And I think that's definitely, not sure that's what you're referring to, but the fact that it's proprietary and that we don't have any transparency around the algorithms is definitely concerning.
That's interesting. I certainly having a better understanding of those algorithms would be helpful. I think I was asking a slightly different question is, where these tools are looking at everything that is on the internet and everything that's available to them, but what happens when important information isn't available to them, to those tools, to those systems? How do we know that there are where the holes are in the answers that we're getting?
Just don't trust any answers that they give you. Assume they're all wrong, but use them to help you synthesize trusted information that you have access to. There.
Okay. You know, looking at what Josh was showing us was really what made me think about this, because you know you're able to access some content but not all content, right?
Yeah, I mean, I think, you know, again, this might get me in trouble. I think publishers have largely thought of articles as PDFs, right? You're getting the subscription or the article processing charge, and then it's a PDF, right? But it is extremely valuable information contained within there, right? It's not just about selling one PDF. And I think this is a big opportunity for this space, is to license this information that can be utilized by these, you know, very powerful machines. And I think if you go back to the early days of OA, it wasn't just OA for humans, it was OA for machines, right? And I think that we're starting to kind of realize, you know, the potential of this. And as the world moves towards more OA, there will be more and more of it incorporated into these machines. But I know for a fact, these large groups that have billions of dollars in funding do not have most of the scholarly publications, right? And so CITE itself is in a pretty kind of interesting position because we spent so much time partnering with publishers to do that. And I think this license has always kind of been confusing. And if you look at Google Scholar, for example, they're showing snippets of things, which is arguably fair use. And so I think, you know, again, there is a lot of very valuable information contained within papers. And I wouldn't, if I was a publisher, view that as, oh, I should be scared, but view this as a huge opportunity for you. You spent so much time curating these things, you know, doing peer review, getting kind of attracting the best authors, all these things to get this amazing article that should not just be treated as a PDF trophy, right? It can be analyzed in many different ways. Like I could imagine just analyzing only the images from scholarly articles, and not for fraud, but maybe for an AI search engine of facts, right? And just giving you things. And so CITE is doing kind of one things around citation statements, but I think publications in many ways can be utilized a lot more. And I think with the machines now to kind of chop them up and analyze them in different ways, you know, hopefully we will start to see some of that research be utilized a lot more, because again, it's very powerful and can inform basically every aspect of life. And it shouldn't just be accessible by Boolean queries and PDFs that you read one at a time. And so I think, again, as an industry, you know, there's a big opportunity here.
So I think a related topic, Ian, it looks like you're interested in answering how AI might improve search engines.
Oh yeah, no, I mean, like the question was, will it be the biggest use for this? And the answer is no.
No, that's a quick answer. Any other opinions around that? No, okay.
I think its biggest use is going to be in micro domains for hyper productivity, and so it will, like at the moment the cost of creating software is very high. That cost is going to be driven way down, and so we will have a massive pent-up demand for the creation of software. Like every time you want to make a change to a user interface, or modify how your computer works, or have a small idea for something that you want to build, up until now, you've either had to wait for a vendor to do that for you or hire software engineers to do it for you. We will move into a domain where you'll just be able to speak to your machine and it will make those changes for you. And I think that's going to be probably one of the biggest areas of applicability for this kind of thing.
Yeah, and I would say even beyond that, right? Like you're wearing the hat as a developer, but you know, there's already kind of this viral music video with these authors that they didn't make, right? And this is coming to art, and maybe the art is quite trite in a lot of people's opinions, but it also is pretty amazing in many cases with these things. And so I think it's going to impact kind of all industries, but I do think kind of the grounding of truth in scholarly publications is a unique kind of thing that we should be aware of and utilize.
Yeah, because the models are a reflection in a secondhand way of our understanding of the world by virtue of being shadows of the language that we've used, which has been co-evolved in terms of how we evolve in our interactions with the world, but they don't interact themselves directly with the world and can't affect it. And so they are kind of Descartesian projection or a platonic projection, but they don't affect the fundamental fire which is creating that image against those walls. And so we still must interact with the world ourselves. We still must support that work, which is that fundamental research. They won't take away our agency. And in fact, they've been created by us to be used by us to help us accelerate our purposes, ends, and means.
And perfect segue to Joris. I think there were several questions on how we can take advantage of these tools that are being developed by the Integrity Hub. Maybe you can answer a couple of those questions.
No, I mean, we want to be an inclusive initiative, of course, so all publishers are welcome. And if you're interested to join the Integrity Hub, again, we are now in pilot phase, and we're going to expand the number of publishers and tools. And in 2024, we hope to be operational with our systems. But if you want to join the program, then just drop me a line.
Right. Great. Well, we just have a couple of minutes. I don't see any other questions that weren't answered by our conversation. Do you guys see anything in the list that needs to be addressed? I think we're ready to wrap up. Any final thoughts? Josh, any final thoughts from you?
No, I mean, I think like we're all kind of, no one's an expert kind of in this space, right? It's so new, it's moving so fast that we all have opinions and conjectures and whatnot. And it's kind of funny for me as a cell biologist to be talking about AI and, citations and things like this. And so I think that's one thing to consider, is that, what we've said might be dramatically different in a couple months. And I think we're just going to have to be on our toes. And so I think it's an exciting time. It is a scary time, but it's powerful. And, I would kind of enjoy the wave a little bit if you can.
Ian, anything to close us out?
So it's very easy to talk about these very wide-ranging ideas, but at the same time, when we come back to how we do our work on a day-to-day basis and how we do that work within the context of the scholarly publishing workflows, we are going to need collaboration. We're going to need integrators. We're going to need these conversations to stay live, to figure out from each other what we're all doing, because there will be change coming to our industry, change to each of our roles. And I think the best way for us as an industry and a group to navigate that is to share as much as we can over the next year or two about what we're doing and how we're finding what works and what doesn't work.
Joris, we have one more minute.
Yeah, just the last, I agree with Josh. So I've been in this industry for, about 25 years. This is really one of I think the big developments in the last 25 years. I'm really also a bit scared, and I think a lot of things are potentially very negative, but it's also a very exciting time. And I also agree with Ian, we have to address this collaboratively as publishers, but I think with all participants in the ecosystem, because these are fundamental changes and we have to make sure we take the best out of them.
Right. Well, with that, I want to thank everybody who attended. I think we had a record attendance of over 200 people today, which was really nice. And it's great that people have taken an interest in this topic, because I also agree with Josh and Ian and Joris that this, I've been working in scholarly publishing for over 30 years, and it's been amazing to watch this paradigm shift happen. I was involved when people started using CD-ROMs, and then when people started using the internet, and now it's yet another major shift in how we're working. So great. Again, thank you everybody, and I look forward to our next best practice webinar.